This lesson we're going to take a look at how to use the trig identities that we've seen to simplify expressions and then to solve for missing trig functions. So starting with trig substitution. So we've got the expression square root of 4 plus x squared, and we're asked to simplify it knowing that x is 2 times the tangent of theta. So we're first going to start by replacing x squared with 2 times tangent of theta. Next, we're going to simplify, so we're going to distribute that square into our expression, so it becomes 4 plus 4 times tangent squared. What I'm hoping you notice is that both of our terms have a common factor of 4, so I'm going to factor that 4 out of both terms. Don't forget that we have a 1 left. Common mistake when factoring is when one of the terms in its entirety is the GCF, that 1 ends up disappearing. So make sure that if you were to distribute, you would get back what you started with. Then we can take the square root of 4, and that leaves us with 1 plus tangent squared theta. Remember, tangent squared equals secant squared minus 1. So if we added that 1 to both sides, we would have 1 plus tangent squared equals secant squared. So this is one of our Pythagorean identities. And then, of course, the square root of secant squared is secant. Let's take a look at another example. Again, we're going to start by substituting for x that 2 times secant squared squaring both terms. This probably looks a little bit familiar. It's very similar to our first example. And in fact, we're going to be using the same Pythagorean identity when we simplify this one. Factoring out that 4, that leaves us with secant squared for our first term, minus 1 when we divide that by 4. Taking the square root of 4, that leaves us with tangent squared. Remember, that's that same Pythagorean identity. Tangent squared equals secant squared minus 1. So when we take the square root of tangent squared, we get tangent. Let's take a look at one more. This time we're substituting 2 times cosine theta in for x. So we replace that x with 2 cosine theta and then square both pieces. So we get 64 minus 16 times 4 cosine squared. So when we multiply our 16 and 4, we get 64. Factoring out that 64, we get 64 times the quantity 1 minus cosine squared. Remember, sine squared plus cosine squared equals 1. Or, if you subtracted cosine squared from both sides, sine squared equals 1 minus cosine squared. So we're going to take square root of 64, replace 1 minus cosine squared with sine squared, and the square root of sine squared is sine.